Kirchhoff's law in electricity is very useful in solving the complicated circuit connections. A. What is the significance of the first law? B. So that its second law describes the conservation of energy. C. Describe the possibility of charge accumulation at the junction point. So we need to understand what is Kirchhoff's law in electricity. So let us discuss in brief, okay? Kirchhoff's law in law. Kirchhoff's law in electricity is very useful in solving the complicated circuit connections. A. What is the significance of the first law? B. So that its second law describes the conservation of energy. C. Describe the possibility of charge accumulation at the junction point. Kirchhoff's law in electricity are of two types. So I am writing Kirchhoff's law, okay, in electricity are of two kind or type, okay. One, Kirchhoff's current law, and it is also called junction rule, okay. So I'm writing in short junction rule, and it is also called Kirchhoff's first law, okay. So this is also called first law. So we can write in short, okay, KCL. Next, Kirchhoff's voltage law, and we apply voltage law to a closed loop. So it is also called loop rule, and it is also called Kirchhoff's second law. So in short, we can write KVL. Okay, so we have this, and we apply Kirchhoff's rule, okay, to junction and to a closed loop. And why we need Kirchhoff's law in electricity, okay? So Kirchhoff's rules, okay, Kirchhoff's rules or law are technique or tools, okay, for solving complex circuit. So we have this. Now let us discuss what is the significance of Kirchhoff's first law. So significance of first law or KCL, okay? And as we know, we apply first law to the junction. So let us understand what is junction, okay? So junction, it is the point of intersection of three, okay, minimum three or more conductors or wires. So we have this. Clear? Now we have this three wires, okay, or conductors. They are meeting at this point. So this point represent junction. So I'm choosing the direction of current randomly, okay. So we have this. Clear? So this is called a junction. And in order to apply Kirchhoff's first law, we use sign convention. Okay. So we can see I1 and I3, they are moving towards junction. Okay. They are moving towards junction. They are moving towards. They are moving towards junction. Whereas I2, okay, it is moving away from junction. So we apply sign convention, okay, for current entering and leaving the junction. So what we do is that current entering the junction, okay, is taken positive, while current leaving the junction is taken negative. So these are the sign convention, okay, we need to follow. Now, the mathematical statement, okay, the mathematical statement of KCL is total current or sum of current at a junction, okay, that is algebraic sum of current at a junction is 0. So this is valid, okay. So this is valid at junction. So the algebraic sum of current into any junction is 0. So this is called Kirchhoff's first law or current law. So we have this, okay. Now KCL, that is Kirchhoff's first law, KCL is based on the law of conservation of electric charge. So it means that no charge can accumulate, okay, no charge can accumulate at the junction. Clear? So we have this. So we can write in this way also. Charge per unit time entering junction equals charge per unit time leaving junction. And we know charge per unit time is current, okay. So we have this. Therefore, from this expression, okay, or relation, we can write in this way, okay. Sum of entering current equals sum of leaving current. So we can state Kirchhoff's first law, okay, as the sum of entering current equals the sum of leaving current, okay. So current entering the junction is always equal to current leaving the junction. So if we don't have this, if sum of entering current is not equal to sum of leaving current, then there is either the creation of charge or destruction of charge which violates the law of conservation of electric charge. So this is to be noted. Okay, so we have this. B, we have this. Okay, so that its second law describes the law of conservation of energy. We need to justify that Kirchhoff's voltage law, that is KVL, supports the law of conservation of energy. So let's explain this. Okay, and we know, I'm writing over here, mathematical statement of KVL, okay, is summation V equals 0. So we have this. Okay, we have this. Now this is valid. Okay, this is valid for any closed loop. So we have this, and KVL is based on the law of conservation of energy. Okay, and we can restate KVL or loop rule as, okay, so I'm writing over here, KVL or loop rule. Okay, KVL or loop rule can be restated as, okay, as electrostatics force is conservative. It is conservative in nature. So work done by it, okay, work done by it along any closed path must be 0. So we have this. Okay, now C, describe the possibility of charge accumulation at the junction. So again, we are coming to Kirchhoff's first law, that is KCL. Okay, now what we know, we need to justify this. Okay, describe the possibility of charge accumulation at the junction point. Is there possibility of charge accumulation at the junction? So what do we get? Okay, if charge or charges, okay, accumulates, okay, accumulates at the junction, then what we get? Then charge per unit time entering junction is not equal to charge per unit time leaving junction. So we have this. So that is charge or charges, okay, charge or charges are created. Okay, so if there is accumulation of charge, okay, if charge accumulates with this condition, okay, that is charge or charges are created or destroyed at the junction, okay, which violates which violates the law of conservation of charge. So we cannot have accumulation. Therefore, so let me write in short, okay? No accumulation of charge or charges at the junction, okay? At the junction point. So we have this, okay?